Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, preferably with some graph paper, or some grid lines if you don't already have them. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. Today we have some other trig graphs. If you're in pre-calculus or math analysis, trigonometry, whatever you want to call it, graphing trigonometric functions is probably one of the more tedious, tougher things that you have to do in the class. It's a good skill to have. Yeah, good skill indeed. Feel free to check out my other video, which covers some more basic examples with sine and cosine. I also have some slightly tougher examples, kind of this level of difficulty, but with sine and cosine. Alright, as you can see, we've got 4 problems here. We have 2 cosecant graphs, a secant graph, and a tangent graph. And I'm going to give you the tips to being able to graph these effectively, quickly. You can go ahead and pause the video and give yourself about, let's say, 15-ish minutes. Try to sort these out, see if you can graph them for yourself first. There's no real strict time limit, but it's really important that you understand how to graph these. People might have slightly different systems. They might do things in a slightly different order. That's fine. I'm just going to show you how I do it here. So when you're ready, and you've already tried these, you can unpause the video, check out how we do it here. Okay, first thing I'm going to do is give myself some spice. Let's get some space in the void. And we're going to start off with this cosecant graph. First thing I want to mention before I even draw grid lines is that cosecant, you should know this, is 1 over sine. And because of that, we're going to be using the sine function as sort of a boundary. And some of the features of the cosecant graph are going to be exactly dependent on what the sine graph would look like. Alright, let's get a grid, see if I can make a decent grid lines. There we go. And we're going to have the midline, which I like to draw here, because we have a vertical shift of 2. I would also like to rewrite the equation first, honestly. So this equation has a negative inside multiplied to the x. I'd rather pull that out, and depending on if you're working with an even or an odd function, it's going to pull a negative and put it outside, or it's just going to leave it the same. For cosecant, it does actually pull it outside. So we have negative 8/5 cosecant of pi over 4 times the quantity x, and then plus 2. Now, of course, the important aspect of cosecant that is so different from sine is that cosecant is undefined when sine equals 0. So we need to be aware of when sine would equal 0. That way we can draw these asymptotes. And what we're essentially going to graph as a boundary curve is we're essentially going to graph negative 8/5 sine of pi over 4x. We're not going to graph it in bold. I might graph it in bold on my whiteboard here, but I can just easily delete it with the erase feature. You might not want to graph the whole sine curve, because then you'll have to just erase it, or maybe do it in a dotted light sketch, maybe in pencil, so that you can erase it and then draw your final graph in pen so that it's bold. Alright, so how do we graph this? Well, we need our quarter marks, and there are a couple different strategies for getting the quarter marks. For example, we see that the period is going to be 2 pi over b, which is going to be 2 pi over pi on 4. That's the same as 2 pi over 1 times 4 over pi. Here the pi's will cancel and gives us a period length of 8. So this one's pretty easy to work with. I'm going to use this method for finding the quarter marks because we start at 0. There's no horizontal shift. So our 0 is just 0. Our pi over 2 is actually 2. Our pi is actually at 4. Our 3 pi over 2 is at 6. And then the completion of our period, the final mark, is at 8. Okay, so we can go ahead and label this 2. I'm only going to draw 1 period of motion. If you'd like to draw 2 full periods of motion, which is often required in class, just go another period. All right, and I'm ready to draw this. Now, one last thing I want to be aware of is this a value. The a value is negative 8/5. You should know that that's not quite 2. If you want an exact value, use a calculator or just divide. It's 1.6, but you should know that 8 is not 2 5s. 10 would be 2 5s, so this is less than 2 5s. This is less than 2. And I also want to notice that we have a negative in front, so the sketch of this is going to go downwards. Let's see, how far down does it go? We're going to have a spot down here at positive 2/5. And then we're also going to go up, but we're not going to go up 2. We're going to go up to about 18/5. Like that. Now let's sketch the curve using these quarter marks. I guess I'll put them sort of bold here for now, since, like I said, I can erase this. But we're going to have a point here on the sine curve, that is, then down, then middle. Normally we would start by going up, but because the a value is negative, we flip that behavior, flip the script. So here is our sine curve, something like that. But that's the boundary curve, and you need to pay attention to this, guys, is that every time we hit through the midline, the cosecant has an asymptote. So I know I'm drawing some bold lines again. In fact, I'm going to erase the sketch of the curve, but I'm going to keep those points on there just so that you can literally see and focus on when it hits the midline. So at 4, it would hit the midline again at 8. It actually starts on the midline. So there's an asymptote that's kind of hard to see because it just overlaps with the y-axis there. So how do we graph from here? Well, cosecant is the reciprocal. All you have to do is take this point and bounce it off that way, bounce it off that way. Same with this point, bounce it up, and there's your graph. If you want to erase some of the lines, like the midline, the asymptote lines, that's okay. Kind of depends on how picky your teacher is. If they want to see all of these features on the graph, even if it looks kind of messy, sometimes that's what they want. Okay, so we started off very gentle. There was no shift, so these quarter marks were very easy to find. Generally, the quarter marks is the most time-consuming portion of drawing these. Okay. So let's move on to the next example. I'll give myself some space again. Oops. Maybe I'll do it this way. I'll pick this one up a little bit, and then I can easily move these ones down. There we are. So here we have a cosecant graph, and it does have this phase shift. That's going to make things a little tricky. Let's first graph the midline. It's the easiest thing to graph. It's at -2. So I'm going to kind of emphasize or show more of the bottom part of this graph, because when we go down 2, that's going to be our midline. And again, we're working with cosecant here. I wanted to keep it the same so that you saw the first example and the second one pretty much follows suit. Now we have to talk about this period and phase shift situation. The period is really easy because there's nothing being multiplied to the x. So the period is just 2 pi over 1, which is 2 pi. Our quarter marks, though, what's up with our quarter marks? We can tell that it's going to be a shift to the right. Do not screw that up. Shift to the right by 5 pi over 6. So how do we find our quarter marks with that? Well, 0 is no longer going to be 0. We're going to add 5 pi over 6. And our pi over 2 is not going to be pi over 2 anymore. We're going to add 5 pi over 6. So do that carefully. Remember that pi over 2, I'll show all my work here for you. We're remember that pi over 2 is just 3 pi over 6. Which gives us a total of 8 pi over 6. And if I want to reduce that, well, my 6 is broken. And this is going to be 4 pi over 3. But it's good to keep it as 8 pi over 6, just conceptually, for this reason. When we go forward to pi, we're going to add another 3 pi over 6. Because now we have 6 pi over 6 plus 5 pi over 6. And that's just 11 pi over 6. So by putting everything over 6, it allows you to see the progression from 5 pi over 6 to 8 pi over 6 is an increase of 3 pi over 6. So you really don't have to worry about solving it every single time. You can just find what the progression is, and that means that our 3 pi over 2, which would be our 3/4 mark, is going to turn into 14 pi over 6. And you can reduce that. You can reduce it by 2 and get 7 pi over 3. That's fine. And then our final position, 2 pi, is going to be at 17 pi over 6. Again, I'm just adding 3 pi over 6 every time. It's pretty easy. So there are my quarter marks. Like I mentioned, I'm only going to graph one period. If you wanted to sketch 2 periods, you could continue going forward. You could even challenge yourself and try to go backwards 1 period. Go back 3 pi over 6 for your next marks, but that could get a little confusing. So let's start from 5 pi over 6. I'm just going to call that, I don't know, right here. 5 pi over 6. Then we go forward to 8 pi over 6, which is the same as 4 pi on 3. And then we go forward to 11 pi over 6. The actual spacing should be pretty even if you can, but the measurement, like, is that big enough or should it be further? It doesn't really matter. Just give yourself enough space to like draw the thing, right? Here's 7 pi over 3. And finally the period ends with 17 pi on 6. Okay, next we need to consider the a value. The a value is square root of 5. Now this is important to notice, is that the square root of 5, well obviously that's bigger than the square root of 4, and we know the square root of 4 is 2, so the square root of 5 is therefore a little bit bigger than 2. And the reason why that's important is because that means it's going to come up to this positive area. Now what do we call this? We don't really have a good name for it. We can just call it square root of 5 minus 2. That's kind of the best that we can do there. And then going downwards, we're going to go further than 2, so that's 2 spaces down. We're just going to go a little further. You don't have to get it exact. And this is going to be the square root of 5. Minus square root of 5 minus 2. Okay? Now it's time to quarter mark it up, because after all, we know that cosecant is the reciprocal of sine. So every time that the sine curve would hit the midline, we get an asymptote. So where would it hit the midline? It would start here at the phase shift, and then it would go up, middle, down, middle. And so this is the boundary curve, the sine curve that sort of bounds or restricts the cosecant curve. But the actual cosecant curve has some asymptotes, and we're able to draw this one. Every time it crosses through the midline, there's an asymptote. Every time it crosses through the midline, and here again it crosses through the midline. A little weird, that point didn't really land, you know what I'm saying? There we go. And we just take these points and bounce off from there. It's very simple to do. Once you have all of the marks and a couple dots, you're really good to go. That is our graph. That's one period. If you wanted to continue drawing it, it would be like that. You can find your quarter marks by going plus 3 pi over 6, plus 3 pi over 6, plus 3 pi over 6. It would look roughly something like this. Okay, let's move on and get the graph of secant. This one is, these two actually are a bit more complicated. They're a bit more involved here. So we're going to take that. We're going to make some space. We like space. Unlimited space on this whiteboard, so let's take advantage of that. Now we have secant, which I'm going to immediately remind you that secant is 1 over cosine. So when we try to find our dots in our boundary curve, it's going to rely on the cosine graph. Okay. So how do we use this? And we have a shift of -4. Well, first we have to fix this whole situation. We have a 7 multiplied on the x, so factor that out, and we're left with x plus 3 pi. When you factor something, you're basically dividing. And when you divide, you're multiplying the denominator. So we're multiplying the denominator by 7, which means our phase shift is 3 pi over 28. Maybe not the nicest in the world, but that's okay. And we have a vertical shift of -4. So most of this stuff is happening below the surface, you might say. Below the x-axis, most of this. Not all of it, but most of it. In fact, I'm going to draw this like here. Something like that. Okay, where does our phase shift take us, by the way? You might want to be aware of that while I'm drawing this midline. The midline is simply at -4, but is at -4. So we're going to draw that little shift down there. And then we're going to go down an additional 5 units. This graph needs to be very, very tall. 1, 2, 3, 4, 5. There we are. And then we need to use our phase shift. So this is going to get shifted to the left. Right, we do the opposite of what our x's tell us. So if it says plus 3 pi over 28, we're actually going to go to the left by 3 pi over 28. Perfect. Okay, now we got to find our quarter marks. We're also going to talk about the period here. So the period is obviously 2 pi over 7. There we go, 2 pi over the b. So 2 pi over 7 is kind of a weird fraction, but that's okay. And then we're going to find where our quarter marks are at. So since we're shifting everything by 3 pi on 28, we're basically going to go to the left by 3 pi over 28. -3 pi over 28. Now here's where it gets a little bit tricky. Because the progression here is not obvious. We want to find our quarter marks. How do we find our quarter marks from this? Quarter marks are 1/4 of the period. So how much would that be? Again, 1/4 means we're going to multiply by 1 over 4. So we get 2 pi over 28. And yes, you can reduce that, but rather than reduce it, we're going to keep it as 2 pi over 28 so that we can find out where the next quarter mark goes. The next quarter mark just adds 2 pi over 28. See how easy that is to do? It's very easy to do now. Now we end up at -1 pi over 28. And then at pi, we're going to add 2 pi over 28 again. This would be at positive pi over 28. And then we're going to add 2 pi over 28 again. And this is going to give us 3 pi over 28. Kind of symmetric so far. And then we're going to go forward again. And this is going to give us 5 pi over 28. So we have our markings. And it's really important to do this before we try to graph. Because when you have a negative shift, you don't know how many quarter marks it's going to take to get into the positive. That means that these 2 quarter marks are both going to be in the negative side. And then you might want to pay attention to the fact that those are evenly spaced, just so that your graph doesn't look so wonky. These are some ways to make your graph look really nice. Since those are evenly spaced, I'm just going to pick a spot here, and I'm going to pick a spot on the other side, and I'm going to call this pi over 28. I'm going to call this negative pi over 28. And the actual starting location is over here at -3 pi over 28. Then we have some more quarter marks. We have one at 3 pi over 28, we also have our final spot at the end of the cycle, which falls on 5 pi over 28, like that. Beautiful, beautiful. Now that we have our quarter marks, we can use the cosine boundary curve. We need to use this carefully because cosine does not begin at the midline. It starts at the a value, which in this case is 5. It's going to take us up 1, 2, 3, 4, 5, right here. And then we go to the midline, and then we go down 5, all the way down. That's right. Let's see, what would that be like? Way down here. And then back to midline, and then back way up here. So the graph of the cosine curve would look something like that. Looks like a giant pit, like a valley or something. Well, we don't need the exact curve, we just need to know when it crosses through midline, because whenever cosine crosses through the midline, secant has an asymptote here and also here. But other than that, we just bounce it, guys. Just bounce that up towards the asymptote. We bounce these ones down. The asymptote technically keeps going forever. It's a vertical line or vertical boundary. And then we have another spot up here. You might remember that secant has kind of a, I used to call it secant sad face. See, this is kind of like the eyes, and this is like the sad face. It does technically continue on the other side, but if we're just graphing one period, you don't really see it unless you graph those other quarter marks. So we'll keep it like that. There's your graph. Beautiful. Ready for the last one? I hope you are. Now the last one is the tangent graph, which is a little bit different. I just want to mention what the quarter marks for tangent normally are, because for tan and cotan, the quarter marks, or I should say the period, is pi over b. The normal period is pi. So the quarter marks are going to happen at pi over 4, pi over 2, 3 pi over 4, and pi. Those are our normal quarter marks. And normally we have the value of 1, we have undefined, we have -1, and then we have 0. In fact, if I also use the starting point, that normally has a value of 0. So the graph looks something for tangent. The graph normally looks something like this. Then we have the asymptote, covers through -1, and just continues doing that sort of behavior. We have to be careful when we quarter mark this and when we identify the period, okay? So let's get ready here. Well, tan is sine over cosine, but I'm not going to graph cosine and I'm not going to graph sine as a boundary curve at all. I do want to mention that tangent is undefined when cosine equals 0. Now, when does cosine normally equal 0? This would happen at the pi over 2 location and the 3 pi over 2 location, and so on and so forth. Let's get a little graph going here. And let's also talk about the period, because we need to factor this out. When you factor out, you're basically multiplying the denominator by 3, and 7 times 3 is 21. This is going to be shifted to the right. Yeah, we're going to shift it to the right by 4 pi over 21. That's a really weird number. So, and let's also talk about the period. The period is pi over b, which is pi over 3. And so our quarter marks are going to happen every pi over 12, because 1/4 of pi over 3. So if I want, I'm basically going to add pi over 12, and that's what makes this problem so tricky, because 4 pi over 21 and pi over 12, those are not nice. This is a bit of a bonus problem, guys. Let's draw the vertical shift on there, just so that we know where the 0 is. We'll call that 1, no big deal. And then we'll take a look at where our quarter marks are going to go. So our starting point here, 0, is actually going to go to 4 pi over 21. my pi over 4 location, not pi over 2. Remember that the first quarter mark for tangent is pi over 4. This is going to go to 4 pi over 21 plus pi over 12. Yeah, this is not so pleasant, guys. We got to find their common denominator. It turns out that their common denominator is 84. If you multiply them together, you get a really big number, right? If you multiply them together, you get, what, 252? But there's a smaller common denominator than that. It's 84. And the way I get this is I multiply this one by 4, and I multiply this one by 7. And so this is going to be 16 pi over 84 plus 7 pi over 84 for a total of 23 pi over 84. What a hideous number. But it doesn't matter what that value actually is, like in a decimal form. We just need to put it somewhere to the right of wherever we started at. So if this is my 4 pi over 21, I'm just going to say, okay, well then here's my 23 pi over 84. And now how do I get to the next one? I have to add pi over 12, but instead I'm going to add 7 pi over 84. That's how I move forward on these quarter marks. And now it's very easy to see that pi over 2, which would normally be the asymptote, is going to be 23 pi over 84 plus 7 pi over 84 for a total of 30 pi over 84. You could also call this 15 pi over 42. Oh, actually, even that reduces. These both reduce by, looks like they're reduced by 6. So this would actually turn into 5 pi over 14. But it doesn't really matter because for the next quarter mark, we're still going to want to add 7 pi over 84. So we get 37 pi over 84. Do you see how I'm doing that? I'm just adding 7 pi over 84. It's very easy to do. And then at the end of the period, the end of the cycle, occurs at 44 pi over 84. So I'm just adding 7 pi over 84 every time. It's going to give me 11 pi over 21, I think. Interesting. And these are my special markings. Now, tangent starts at the midline. So tangent's going to begin right here. Let's put our other marks on here. I guess I'll just call this one the 5 pi over 14. Then we can call the next one, I think it was 37 pi over 84. Notice how the actual numbers don't matter too much. It does on your test, because then you're going to get it wrong, but it's spaced out the same. It's not really a mystery of what happens. It just moves the same amount. This is just fraction work to find out what the values are. So we have an asymptote right here where I should probably move all my quarter mark work. Oopsie. Don't want to move that graph as well. All my quarter mark stuff. Oh, why didn't everyone come to join the party? There we go. Everyone should join the party here. I'll move the quarter marks here. Thank you for bearing with me during this. There we go. That's a little bit better. Now we're going to have an asymptote in the middle. One funny way to remember that is that when you get a tan, you wear half of your clothes. So on tangent's graph, you have an asymptote halfway through the period. Half your clothes with a tan, half the period for the asymptote. Kind of like that. And now this special location, this is 1. This special location is going to go up here. It's getting stretched quite a lot because the A value is 12. So it's going to go up 12, and that will be a portion of this tangent graph. Now on the other hand, on this 3/4 mark, it's going to go down by 12. So we're going to end up at negative 11. And I kind of missed it. It's a little better. Kind of technically got it there now. This is one period of tangent. It does look a little weird, so what I kind of want to do is I want to go a little further. Our next location would be normally the 5 pi over 4 location. I'm just going to keep adding 7 pi over 84. So this is going to be 51 pi over 84. Those do both reduce by 3. So if I wanted to call this 17 pi over 28, that's also valid. The next asymptote would be at 6 pi over 4, which is just 3 pi over 2. And this is going to go to 58 pi over 84. This also reduces to 29 pi over 42. Okay, so that just gets me to the next asymptote location. It's not a huge deal of where exactly that is at. But let's see, I've already forgotten. Where did I say that was going to be at? Well, if that was 44, this would be 51 pi over 84. Ah, yes, 17 pi over 28. And then if we go further, we'll have 58 pi over 84, which is 29 pi over 42. See all these different denominators? Kind of wild, right? 14, 84, 21, 28. So here we repeat the pattern. We go up to the 13, I guess it is. And we have the asymptote halfway through the next period. Okay, so these graphs are definitely not as easy. A good challenge would be to ask you, if the asymptote going to the left, is this going to be on the right side, on the positive side, or is it going to be on the negative side? Maybe a little bonus problem. If you're still watching this, you can try that out and see what you get. I'm going to do this here. We're going to go backwards. So from 4 pi over 21, we're going to go backwards. 4 pi over 21, of course, is 16 pi over 84. But if we go backwards by 7 pi over 84, that's going to leave us at 9 pi over 84. And then if we go backwards again, so this is our next quarter mark going backwards, and then if we subtract another 7 pi over 84, we're going to end up at 2 pi over 84, which is 1 pi over 41. The important part here, this is positive. So the next asymptote will be in the positive region, like barely right here. You can draw another spot here, have it go through there like that. And here we just have a little pi over 41 action there. And here we have a 9 pi over 84, which we could also call 3 pi over 28. Okay, I think I really kind of beat a dead horse with that. We went a little over time than I intended. But it's important that you know how to carefully mark your quarter marks, and then you just have to rely on the shape of the graphs. That's enough blabbing to me. Catch you guys next time.